Hey, hello.
Hello.
Am I audible?
Oh, let me turn my volume up.
Yeah, you're audible to me.
Okay, great. Awesome. This is my first one, so I'm not sure how it goes, so I'll let you lead.
Cool. I guess yeah. So you are chose for the practice interview for Google. So I'm assuming like you have an interview with Google. Is that a right assumption, or you're
So
just
it's
preparing
actually,
generally?
yeah, the interview is actually with DoorDash,
Mhm.
but I do plan on setting one up with Google soon.
Understood. Understood. And like, do you know like what is the coding interview format for DoorDash? Do they expect you to have a compilable code, or do they expect you just to write a code? And like, do you have any understanding about that?
Um, they do code pair,
Okay.
and I think they have test cases that they paste in and run it.
Understood. Cool. Okay.
Yeah.
So they expect an executable code.
hmm
Sure. Cool. Awesome. Yeah. So initial 45 minutes we will focus on the coding problems, and I will keep like last 10-15 minutes for feedback, like how you did, what you could have done better in terms of interview or
Awesome.
preparation. Cool. Awesome. So here's the first question. So you have a directed graph of n nodes. They are labeled from 0 to n minus 1, and your task is to find the length of the longest path out of each node. So if you take a look at example, there is an edge from 0 to 1. That's why the in output array
hmm
uh, at index 0 there is 1, and there is no edge going out of 1, so 0 for index 1. From 2 there is one edge going from 2 to 1, and that's the longest path of size 1. From 3 you can go to 2, and from 2 you can go to 1. So that's why for 3 it's 2, because from 3 the longest path is of length 2.
Okay, sounds good. Um, are there cycles in the graph, or do I need
Uh,
to like
yeah,
different?
that's a spot on question. Yeah, you can assume for first version there is no cycle.
Okay, so I can assume there's no cycles.
Yeah.
It's directed and length of longest path out of each node. Okay. So right off the bat, I'm thinking that I just like DFS through the graph
Mm-hmm.
and like memorize um, the length of the longest at each step, so I can
Mm-hmm.
reuse that. Let me think for 1 second to see if there's any would be any issues with that. With no cycles, I think that would be fine. Okay.
Mm-hmm.
Um, so what is the graph given me in? Is it like an adjacency list or something?
Oh, that's a good question. Like, yeah, you are free to assume any form which will be more suitable for your implementation. Adjacency list, adjacency matrix, and whatever suits better to your implementation. You can assume that's the input.
Okay. All right. Cool. um, and let me choose my language here. I'll use. So I've been just doing full stack JavaScript for the
Mm-hmm.
past few years on front end and back end. So I'll use that since I'm most comfortable in it.
Sure.
And this is the first time using this interface too. So
Understand.
I think I'm doing it the right way. Hopefully, I don't need Lodash or any of this stuff. So I can make up the input and everything myself, and I'll make my own test cases and everything.
Sure.
Well, I'll start with just the one that you've given me.
Mm-hmm.
So the edges, so we have an edge from 0 to 1, and an edge from 2 to 1, an edge from 3 to 2.
Hmm.
Okay, so I want to have a way to check my test. So I'm
Hmm.
starting with, I guess, like the test harness, and then I'll work on the actual algorithm.
Sure. That's okay. We can just print it and see like if it is what it is printing.
Oh, okay. That works too. So we'll just start with this one test case, but we can add more.
Hmm.
Excuse me. Later. Okay. In 1 second to think about how I want to approach this. So I'm going to iterate through all the vertexes
Hmm.
and find the longest path at each vertex
Hmm.
and um, and then memorize that and use that for future, finding longest paths at future vertexes.
Sure.
And then I can assume that in my answer, the index of this is going to correspond to the vertex. So like this would be vertex 0, vertex
Right.
1, vertex 2, vertex 3, right? Okay.
Right.
Okay. Um, so I can do one of two things. I can just build like an actual graph with nodes pointing to other nodes, um,
Hmm.
or I could just use I could build a map out of the adjacency
Hmm.
to know what nodes to go to next. So I think I'll do that. I think I'll just make a map of each vertex
Hmm.
to its neighbors. I'll do it that way. For each vertex A, um, so A goes to B. So this is going to be an array of its neighbors. Okay. So what this does is it gets the neighbors if we already have any for vertex A. Otherwise, initializes empty array.
Mhm.
It pushes B to that um, and sets neighbors to A, which if it's already set, then it doesn't matter because it's the array that we already have already gotten from it. One question is that can I assume that there's not duplicate vertices or duplicate entries in the adjacency list? Like, for example, can I assume that this would be invalid, that each entry in the adjacency list is unique?
Oh, that's a good point. Yeah, you can assume that each entry in the adjacency list is uh, in the input is unique and it does not form a cycle.
Okay, so this gets me a map of each vertex to its neighbors. So now I just need to DFS
Mhm.
through each vertex. The keys in the map will be the vertexes that I'll loop through.
Mhm.
And I need something to hold what how long the longest path is.
Mhm.
I'll call it answer. That is what I'm returning. So answer V is what I'm trying to find
Mhm.
for one of these. Answer V equals what?
Mhm.
So I think what I want to do here is answer V equals SP.
Mhm.
And so now this is what I want to find out. And I think I will add the memoizing after I just do the basic DFS algorithm. So my base case is going to be um, vertexes that don't have any more neighbors. Excuse me, sorry. Let's see. So the length of my path is going to be 1, because my current vertex, plus the longest length of any of my neighbor vertices. So I'm going to initialize my path to 1, and then I want to loop through all my neighbors.
Mhm.
And I want to find the longest, the neighbor with the longest path. Okay, so this gives me my longest neighbor path, and
Mhm.
if I count myself, my current vertex that I'm at, then it's longest neighbor path plus one. And if I don't have any neighbors,
Mhm.
then um, it won't even DFS. So effectively, I have my base case here, um, and it will just add, 0 plus um, one. So for example, the vertex one right here would not DFS any further and do 0 plus one. Um, so at this point, I could run it and see if it actually works before doing my memoization, but the memoizing is actually pretty easy, so I think I'm just going to add it in right now. So what I'm memoizing is, if I've already found the longest path for a vertex, I don't need to DFS into it
Mhm.
any further. So if memo v like find, then I can just return v, and then I need to make sure I actually memoize it over here. So memo equals this, and then I can just return v.
Memo.
Okay, and hopefully I didn't make a mistake. So we're about to find out. How do you run this? Is there a where's the execute code button?
Yeah.
Oh, here.
Top left. Yeah.
Oh, and control enter. Nice. Oh, input.
I think it's
Okay.
because of this thing. You would require one more thing because you're taking one of the input as of one test case. Let's try to run now. Yeah. No, that problem is gone.
Oh, yes. Yeah, thank you. You're right. Yep. Okay, so let's see what problem I have here. Map.getV, it's not a function or value. So that means it's probably undefined. So I didn't get a mapping of that particular
Hmm.
index, which is odd. So I just have probably a relatively straightforward bug here. Let me just print out my map first.
Mhm.
See if it didn't really mess something up. Okay, so map 0.
No, you have not entry for key one. Is that an issue?
Yeah, yeah, that's right. So,
Uh,
okay, right, okay. Yeah, that makes sense. I think what I'll do here, there's a lot of ways that I could approach this, but
mhm.
I think what I'll do here is I'll just initialize the map first. Do this. That way I have all the vertexes in my map.
No, but I don't know why. But we are iterating those just the keys, right? The error should not be there.
Well, I don't have a key for this one because
Yeah,
right here I'm in
but
settings.
that doesn't matter. You're just iterating through the keys only which are there. So this here is still different.
Right, true. Yeah, I think I have multiple problems here.
Hmm.
Let me get this one in first just so I know that I have
Sure.
all of them, and then I'll look at that one.
Sure.
Need that anymore. Need that. And so I at least should have each vertex in the map now, which I didn't before. And now I can see what I'm doing wrong with this. Oops. Oh man. Okay. The
Yeah,
number
that's
of edges is nothing to do with
yeah.
the number of vertices that I have. I guess so I could do one of two things. I could either just go through all the edges and find all the vertices,
Hmm.
or uh, that could be
You can
part of
take,
the.
yeah, for simplicity, you can assume as an input n, the extra input n, which represents the number of nodes.
Okay, so I'll make it part of the input. I'll just call this edges, and I'll just call this n as in like the number of vertices. In this
Mm.
case, n would be
4.
n would be 4, and it's zero based. Okay, so now I have n and I have edges. Structure that here. Okay. So this my map should hopefully be set up right. Yeah. Excuse me. Okay, so my map is initialized correctly. Um, that's just bring my edges again, and in my map here, I have 0 goes to 1, 1 goes to nothing, 2 goes to 1, and 3 goes to 2. So at this point, my map is now correct, and my answer is just wrong, because the answer should be 1, 0, 1, and 2, right? So it looks like every single one of them is just off by 1.
Hmm.
So let's see what I did wrong with my off by 1. Okay, I think what I've done here is I've assumed that I'm counting the vertex as part of the path. So like the longest path at 1, and what I did would be 1, but in what you're looking for it'd be 0. So I want to not count my current vertex when it comes to the counting the longest path. Is that right? So for example,
Hmm.
the longest path at 0, it wouldn't be 2, it would just be 1. So it's not counting your current vertex.
Hmm.
Okay?
All right.
I'm based off of what you have here, right? That's what you want, right?
Yeah. Number of edges. Yeah, it's number of edges, not number
Oh,
of
number of
nodes.
edges. Okay, yeah, got you. Number of edges. Yep, makes sense. Okay. So I think I just want to put my
Hmm.
one right here instead. Okay, that gives me the answer I want. Um,
Cool. Awesome.
mhm. I could add more test cases, or if you want to, uh,
No, we'll just have one follow-up. Like,
mhm.
let's assume that there could be cycles. What will happen to your code?
Got you. So if there can be cycles, then I would just get a Stack Overflow because it would just keep
Mm-hmm.
DFSing.
Mm-hmm.
Um, so there's two things I could do. I could either detect any cycles
Mm-hmm.
up front before I even run this longest path algorithm,
Mm-hmm.
or I can keep track of visited vertices and
Mm-hmm.
detect a cycle that way.
Cool. Awesome. Let me just add something. Yeah. So let's say there is an age from 0 to 1 and also an age from 1 to 0. So in that case, I expect like output should be like infinity for 0, infinity for 1 because they can keep looping in the cycle. Also infinity for 2 because, oh yeah, in this case for everyone it should be uh, infinity. But let's say
Hmm.
that if this is the case, then for Apart from 3, every node should be infinity because they can reach to a cycle and loop into that cycle infinitely.
Okay. All right, let me add this test cases here. Keep my current one, just add a new one. Okay. So we have an edge from 0 to 1,
Uh-huh.
an edge from 1 to 0,
Uh-huh.
an edge from 2 to 1, and an edge from 2 to 3. And then the answer you'd be expecting is, okay, yeah, that's infinity because you can just go back and forth. 2 is infinity because it goes to 1, which just goes back and forth. Yeah, so, and then 3 would be 0. Okay, that makes sense. Okay, let me think real quick. So I think for the visited, I want to do like a backtracking. So every time I go down a path, I'll visit it, but like when I come back up through it, then I unvisit it. So let me put here. And I guess the first thing I'll do is if I've DFS and I've come back to a path that I've visited,
Mm-hmm.
and that's infinity.
Mm-hmm.
It means I have a cycle.
Mm-hmm.
So yeah, so I visited here. Okay, and then down here I can unvisit this path. And I should still get the memoization of infinity. So like if I find a
Mm-hmm.
cycle deep within a path, um, then this PFS neighbor will return infinity. And then I'm pretty sure that 1 plus infinity in JavaScript is
Mm-hmm.
just infinity. Uh, and then math that max will make it so that longest neighbor path is infinity, and then that will get memoized. So I think that should work. Yeah, let me try. Yeah, there we go.
Cool.
Infinity and 0.
Cool, awesome. So what is the complexity of this logic for the graph of n nodes, v nodes, and e edges?
Uh, what was the question one more time? What's the runtime complexity?
Yeah, run and space both.
Got you. It's, let's see. So I'm visiting each vertex, and then I'm visiting each neighbor for each vertex. So that'd be each edge,
Mm-hmm.
and because I'm memoizing, then I don't do it more than once. So it's going to be O of V plus E, vertexes plus
Mm-hmm.
edges.
Mm-hmm.
And then the
Yeah,
memory complexity will be the same, V plus E, because I'm storing a map with each vertex and then its neighbors. So effectively, it scales with the number of edges as well, V plus E.
I understand. Um, cool. Um, so yeah, so let's say that uh, I have one more follow for this. So let's
Hmm.
say here we are assuming every edge is of length 1, right? So the longest path is sum of is number of edges in the path. What if rather than having a unit weight for each edge, there could be a specific weight for each edge, and now the
Hmm.
longest path is sum of these weights in any path.
Okay, got you. Okay.
So what
Well,
changes you would require in your code?
yeah. At the outset, this is where I'm adding. So I'm adding
Mm-hmm.
one each time. So basically, my edge
Mm-hmm.
weight effectively at this point is one because of this right here.
Understand. Mm-hmm.
Um, so that's where I would look at. Let me think for a second to see if just putting the weight there would solve it, or if I need to do something more complicated. Um, I'm thinking about it because you could have negative.
Oh yeah, that's a good point. Assume that these weights are non-negative. They are non-zero
Okay.
also. They are greater
Okay.
than zero.
Okay. Got you. So all the weights are positive.
Yeah, positive and yeah, non-zero.
If that's the case, then I think um, putting the weight right here would be sufficient. But let me think for a second if there's a problem with that. And DFSing, so I am checking every path. I think that would be sufficient.
Yeah,
If it's positive, just changing this to whatever the weight is. Would you like me to add a test case for that, or
yeah,
okay?
that would be great.
Okay, let me make oops, make one up here. And they can each have different weights, right? Okay.
Yeah, they can have different weight, different or same. Yeah.
I'll modify these ones right here
Mm-hmm.
just to have the weight as a third item here in my adjacency graph,
Mm-hmm.
and these are just all ones, and then I'll modify my code to take that into account, and then I'll make a new test case.
So
Okay, so the neighbors, so I'm going to push this along with the,
mm-hmm.
and this is where I get my neighbor. And these are all just going to be tuples,
Mm-hmm.
so neighbor to weight. So I'm going to run this and hopefully I get the same answers, and then I'll add a test case.
Cool,
Okay,
awesome.
so I'm confident there, and now let me add a test case with different weights. And I'll add one. I'll start with one that's doesn't have any cycles, although it shouldn't matter. The cycles should be fine. Okay. I can actually let me do the first one and just add different things to make the answer change. So this is our first one, and it was 0 to 1, 2 to 1, and 3 to 2. And then our expected answer for that was 1, 0, 1, 2, right? So I want to make it different. Now this is a little too simple, so maybe we'll start with a different or a
Great.
more complicated test case next. But I'm just going to start real simple and just change the weight from 0 to 1 to be
Mm-hmm.
more than the. So I'm going to make the weight of this one, let's just
5, that's
say,
a 5.
yeah, 4, yeah, something. Um, let me see how I want to represent that. I
Yeah.
want to make it easy to read, so I'll just
Mm-hmm.
do like. Um, okay, so from 3, that was. Let me start from the beginning here. So the longest 0, this should be 4 now. This
Mm-hmm.
will still be 0. This will be. I'm going to go ahead and make this a 2 right here. This will be 2, and then this one would be 3.
Mm-hmm. I
That's,
want to add one more detail here. Let's say like this.
oh yeah, definitely.
Uh, 4. Yeah.
Okay, cool. So, okay, so that's going to be 4.
Output should be like
Mhm.
5, comma 0.
Okay, perfect. Oh, 1 second. It's, is that right? This should be 2, right? That vertex is vertex
Yeah,
2.
that's the worst text too, right?
Okay. Okay, yeah. I have a hard time reading it now. Let me put
Mm-hmm.
spaces between these vertexes just so it's okay. That's a little bit easier for me to read. 0, 1, 2, 3, 4 is my vertexes. This is 4. That's 0. This would be 2. That would be 5. Yep, that's right. And this would be 0. Okay, yep. And 1, 4, 2, 1, 2, 3, 2, 2, 1, and 3, 4, 5. Perfect. Okay. I'll go ahead and run it.
Mm-hmm.
Oops, I have an issue.
Oh, it printed for first two cases. Okay.
1 second. Let me think about what I
Oh,
did wrong.
sorry. My bad. Yeah. This end should be fine now.
Oh, yeah, yeah, that's right. Yeah. Thank you. So 40250. Yep, there we go.
Yep. Awesome. Cool. Yeah. So that's it. Like that's it from my side. For this question.
Hmm.
Mm, yep. So, basically, let's move to the feedback part of it.
Okay, great.
Cool, awesome. So basically, I really like the fact that you nailed down the classification question you did ask, like whether there are cycles, because like that's the tricky part. Many
Hmm.
candidates just missed asking this question and they solve for non-cycles, and then there is awkward situation when I introduce a test case with cycle. So
Hmm.
yeah, so kudos for that. Like you really spent some time understanding the problem, understanding what kind of input is provided. So keep doing that. That shows the maturity and seniority of a developer.
Hmm.
So yeah, so that's a good thing you are doing. Then like you shared your approach that you could do it with DFS and memorization. That was spot on. Like kudos for cracking it that in no time.
Mhm.
Did you also understand like this could have been solved by breadth first search also instead of depth first search?
Yes. So I personally find DFS easier to think about. So
Mm-hmm.
I usually, when it can be solved both ways, I usually go for DFS. But
Understood.
I should have brought up DFS too, though. That's a good point. Yeah, I should have
Yeah,
brought that.
my suggestion is like if it doesn't crosses your mind, that's okay. If you have one good solution for to share that. But if it comes in your mind like okay, both BFS and DFS could be used, do
Mm-hmm.
mention that, and then you can always reason about like why you use DFS because you can say that okay, I am good at writing recursion would be easier, so that's
Mm-hmm.
why I use DFS. So that shows another trait of a senior software developer that like you can come up with multiple solutions and do a trade-off. So
Okay.
if you come in a situation where there are multiple solutions and you choose one of them,
Mm-hmm.
please do that. Do brought up that for a discussion. It will take just 1 or 2 extra minutes, but it will show the seniority. And at least in Google, like even the coding interview determines the levels. So
Mm-hmm.
these small things do matter. Um,
Awesome.
yeah. Apart from that, like I would like you to have some changes in the way you approach. Like after sharing your thought process, like after sharing your approach, my suggestion would be follow that approach discussion by complexity analysis, even when the interviewer did not ask for it. It will
Mm-hmm.
take care of two things. Like you will always be sharing these details, and it won't depend upon whether interviewer asks you the complexity or not. If you share it by default, they will go into the notes of interviewer because it
Okay.
might happen that some interviewer might not ask it and they did not note it, and it might happen that you could not identify the complexity, right?
Yep.
And another
That's great.
problem, yeah. So another problem is like sometimes I've seen candidates which have shared the optimal solution, and in their mind they are thinking about optimizing it further. And I was thinking like, okay, they are just thinking about implementation details. So just to
Mm-hmm.
clarify that communication, share your approach, share the complexity analysis, and ask the interviewer straightforward, do you want me to code this or do you want me to optimize it further? So you can
Mm-hmm.
so that it will be a clear communication. Both ways it shouldn't happen that you wrote a code for unoptimized solution or you try optimizing already optimized solution and waste some time. To
Mm-hmm.
avoid both this situation, my suggestion would be like follow your approach by complexity discussion and ask interviewers that whether you want me to write this code or not.
Okay. Yeah. That's great advice.
Cool, awesome. Yeah, I think yeah, your coding was was good. Yeah, there was hardly any issues or bugs in your code, and you were able to debug it.
Mm-hmm.
One little extra thing, I know like in DoorDash, you have to write a code and test it. But if
Mm-hmm.
you happen to have interview with Google, your editor wouldn't be highlighting any syntax or something. It would be a plain text editor.
Mm-hmm.
They won't be like highlighting for syntax or something. Your code would not be run against any input. So your code
Okay.
has to be dry run. So once you are done with the DoorDash interview, and if you have any interview with Google, do practice for in a text mode where there are no highlighting and stuff, so
Okay.
that like it won't be a new thing for you.
Okay. Yeah, definitely. That's good to know. Awesome.
Cool.
Um,
I
this would be like a fairly representative problem at Google. I know it could be, harder, easier, if they choose the problem, but this would be like a fairly representative problem of a Google interview.
Yeah,
Awesome.
yeah, it would be a fairly representative problem at Google. Yeah, I was expecting like exact same number of follow-ups, and we did cover it. One last
Hmm.
follow-up which you can think and take it back with you is like you do not need to provide a solution for that, but like how would you solve this problem if graph is too large and cannot be fitted in memory?
Gotcha.
So yeah, so you just spend some time thinking about it, uh,
Hmm.
because like these are the open-ended problems. Question. This is open-ended question. Interviewer do like to ask this question to differentiate between like five or four, like how a candidate do in case of like open-ended problem, like what details you can ask back to the interviewer, like
Hmm.
or what kind of different approach may not be true, may not be correct, but comes to your mind.
Hmm.
So yeah,
Okay. Yeah.
cool. I think yeah. So we still have time. Do you have any specific questions about interview process at Google or any other thing?
No, this is super helpful.
Mm-hmm.
I'm glad that I got it done in less than the time that was needed. I'll let you have your extra, 10 minutes for that. But yeah, thank you so much. This is good. I like this. This starts to give me more confidence in the interview. I've actually never done a on-site thing interview yet, so uh, new experience for me, and I'm pretty excited.
Cool, awesome. Yeah, in that case, like, yeah, I will. That's it for today, and all the best for your interviews. Yeah, I'm hopeful
Awesome.
that there would be positive result. Bye bye.
Thank you so much. All right. Appreciate it. Have a good day.
You too.